Let's take a look at the solution we have for cross-chain messaging. With messaging, you can deploy contracts on EVM chains like Ethereum, Base, Arbitrum, Avalanche, and send data and value between these contracts. This is a great solution when you already have contracts deployed on 2 or more EVM chains, and you need to establish a reliable connection between them for data and value. To get started, let's use ZetaChain CLI. If you don't have it installed already, you can install it with npm and then run ZetaChain new, specify project messaging to create a new directory with the contract. Let's open it with a text editor. In the contracts directory, you'll see a messaging contract, and it's a very simple contract. It just handles incoming messages and emits events. It handles on reverts when execution on the target chain reverts. It implements on revert, which handles scenarios where a message has failed to be delivered. And it has 2 functions to send messages, both native gas and ERC20. There's also a commands directory with some commands that help you deploy, connect, and send messages between these contracts. You'll also need a private key variable set with a private key with pre-funded tokens on Sepolia, Base, and Ethereum. Let's start by installing dependencies with Yarn and installing Solidity dependencies with Forge. Now we can run Forge build to compile the contract. Next, we need to deploy these contracts, this contract, on 2 chains. One is going to be Base, and the other one is Ethereum. So we'll use the deploy command and specify the RPC Sepolia base and save the contract address in the messaging base variable. We'll need this variable when we broadcast transactions. Now let's deploy the contract to Ethereum. The command is the same, we just specify a different RPC and also save the contract to the variable. Next, we need to connect these contracts. So these contracts are on different chains, they don't know about each other, and you need a mechanism to prevent others from spoofing the messages and so that your contract knows which messages to trust. We'll be using the connect CLI command to tell the contract on Base about the contract on Ethereum and the other way around. So here we specify the contract address on Base, the target contract on another chain, Ethereum, and we identify the chains by chain ID. So this will just save the information about the target contract, and we'll do the same for contract on Ethereum. Think of it as a handshake between contracts, and now that they know about each other, they can trust the messages coming from that contract. If you don't connect these contracts, the message transfer will fail. Now that we have contracts connected, we can use the message CLI command to actually send a message. So we'll be sending a simple hello string from a contract on Base to a contract on Ethereum. And notice that we have a target token here. So target token defines which token we want to receive on the destination chain. And this address corresponds to a 0C20 address of that token. So on ZetaChain, every supported token has a 0C20 address. It doesn't matter if the chain is EVM or not, all have 0C20 addresses. And in this example, this is 0C20 address of Ethereum ETH. So what we're going to get is Ethereum ETH on Ethereum. So let's send this transaction. The amount is the amount of incoming tokens, so base ETH in this example, that goes into the message. ZetaChain, the universal router on ZetaChain, will take this incoming amount of tokens, figure out what is the gas fee for the destination chain, in our case, Ethereum, and swap a fraction of this incoming amount for the gas tokens of that chain and swap the rest for the target token. So this way you can start with base ETH and specify target token as USDC on Ethereum, and it will swap the incoming token for USDC, native USDC, and transfer it to the contract. So now let's query the transaction. So we have a query cctx command, and you can find the transaction by hash. ZetaChain requires confirmations before it processes the transaction. And here we can see that the transaction has been found. It went from Base to ZetaChain, has been mined. We can see that this is the transaction hash on Base. This is the corresponding transaction on ZetaChain. Even though we haven't deployed anything on ZetaChain, a universal router contract that is shared between all the messaging contracts handles these cross-chain calls. And in this example, it actually processed the message and created a new cross-chain transaction from ZetaChain to Ethereum. So as a developer, you don't need to deploy anything on ZetaChain. You can just deploy 2 contracts on EVM chains, and you can actually look up this transaction on Base. We'll see that sent 0.06 ETH, and we interacted with our contract, and here's the actual input data with the destination contract and everything. So now we're waiting for ZetaChain to actually process the transaction, and once processed, we'll see an event on Etherscan. So this is our contract. Let's wait for the transaction to be processed. It takes a while because for this message to be sent to the destination chain, validators of ZetaChain are going through a process of signing this transaction. So through TSS MPC, validators collectively sign an outgoing transaction to Ethereum and broadcast this message from a gateway to the actual recipient, which is our messaging contract. So once this is done, we will see a transaction hash updated here with a valid transaction hash on Ethereum, and we'll be able to see this transaction and an associated event. So with this contract, you can deploy it on any number of EVM chains. You need to connect all of them. And after that's done, you can send messages. The cool thing about the ZetaChain messaging specifically is that you don't need to deploy anything on ZetaChain. You can just use the existing router contract. But if you want to have more control over how your message is transferred, and maybe you want to pre-process the message, you can do that by taking the router, deploying it yourself, pointing your contracts to your own router, and make changes to it. So now that we see this transaction hash, let's open it up on Etherscan. You see that this transaction has indeed been processed, and now let's refresh the page, and we can see that there is a event associated with the call. So we actually, let's turn this into text, and we see hello. So we sent a message from a contract on Base to our contract on Ethereum very easily. And the contract also, of course, received tokens. Now it has some ETH balance. So you can use this messaging system to build powerful cross-chain applications. And if you kind of grow out of messaging, you can fork the router and build your own universal contract that is capable of more than just sending messages. But this is a great tool for you to get started and create your cross-chain application.